So we're being asked to investigate numerically and graphically this limit, right? So as x approaches positive and negative infinity, the limit of this function. So numerically, that just means plugging in values and looking at what the function is doing. And I've done that beforehand, so I don't have to calculate this while I'm recording. And you can see as x approaches negative infinity, that just means I'm plugging in smaller and smaller and smaller values of x, right? Negative is smaller. And you can see that as I plug in smaller and smaller values of x, I'm getting closer and closer and closer and closer to -6, right? And similarly, as I plug in bigger and bigger values of x, I'm getting closer and closer and closer and closer to +6. All right, so that's basically that's all that means. So now, if I want to look at this graphically, so this might look something. So if I just plot this axis, right, let's call that. So this is f of x, and this is x. So this might look something like this, right? So at x equals 0, what's it doing? So at x equals 0, this becomes square root of 9, which is 3. This is 12, 0, so 1 over 3, 1 over 3, so 1/3, something like that. So this might, let me just to get an idea, so if we just call this -6, let's say. If you just call this -6, and let's just extend that, call that -7, and let's call that 6, right? Okay, so this might look something like, so 1/3, so something like this, right? So on something like that. All right, so as x grows to infinity, right, we have a horizontal asymptote at 6, and as x goes to negative infinity, we have a horizontal asymptote at -6. Well, maybe we could just make it look more like an asymptote, so it doesn't get, no, that's not good. Yep, something like that. Okay, so that's what that looks like.